we are going to be taking a peek again at some things with statistical analysis. Now, I just want to do a couple of things quick just to make sure that we're on the right track here. So my first question would be, okay, if we were taking a look at number 1, this is kind of a review of yesterday. When we're looking at our measures of central tendency, we're looking at mean, median, and mode. What might be my best option for number 1? If you're not sure, flip back to the front page. What's that? Median. Now, I've had some people before say, well, wait a minute, you said median, but we just got done yesterday saying with median, okay, it has an outlier. Okay, I see the 299 is an outlier, but no big gaps in the middle of the data. Well, I'm looking at the middle of that list, and the middle is 299, and then it's like 11 and 15 around the edges. Isn't that a big gap? Remember, the other thing we have to remember with median is it's ordered data. So before I'd actually go find the median of this, I'd have to stop for a second, go back, and put these in order from least to greatest, because now I can deal with that outlier. It's not in the middle of my data, and I'd actually be able to go to the middle of the list and find it. So don't get caught off guard just thinking, okay, I know it's median. But then when you went to calculate it, do something silly like say the median was 299.7, because, well, that would be silly. Right, one more up here, just to make sure we're all right. Number 3. I would tend to lean towards median myself. Because again, we get a couple of outliers here that are kind of out there. So those of you that are saying median, I would agree. If you tried to give me mode, you might be able to talk me into that, since there's only 7 numbers and 2 of them are 250, but median's probably going to be our best route as far as that one goes. What about if we talk population sample? What about number 6? 10th graders at a high school are surveyed about school athletics. Okay, it's going to depend on which way that you look at it. If you're looking at it, well, it's a high school and it's only 10th graders, maybe you say sample, because you're thinking, there's 9th and 11th and 12th graders. And I agree, if the word all would have been there, I'd have been all over population. Because you're not sure which 10th graders, maybe they only asked 10 or 20 of them, you're not sure. But if you were going to say population on that, I'd explain it and say, oh, if all 10th graders were, then you might be able to talk me into it. Okay. So just kind of, again, thinking the whole group versus just a part is basically what we're looking at with those. And again, I'm kind of just going into review mode. If you see one, you're like, wait a minute, can we talk about that one a little more? I'd be happy to. I just wanted to make sure I didn't get you too slowed down here. Okay, for instance, 9. A survey of 728 random people found that 72% prefer comedies over romantic movies. What's the margin of sampling error, number 1, and the likely interval, number 2, that contain the percent of the population? This is when we spoke yesterday about how do we calculate that margin of sampling error. And we calculate it by using this mini formula, plus or minus 1 over the square root of n. N being the number of people that we're surveying. So, if I pop that up and we get that taken care of here, 1 divided by the square root of 728. And again, the margin of sampling error, we normally come back with a percentage on this, and normally you're going to go to a whole percentage, or at least like to a 10th, let's say. Let's just go to a 10th. So if we go to a 10th of a percent here, it looks in this case that our margin of sampling error would be about 3.7%. And what that means to us is when we're watching TV and we see something like this come up, or during a political election, we see something like this come up, and they say 72% plus minus some number, I'm going to subtract the 3.7 to get my lower end, and I'm going to add my 3.7 to get the upper end. Thank you. So the more people I survey, the narrower that number is going to be, that margin of sampling error. So watch that sometime. If you see on TV and they put that little plus minus number at the bottom, you actually can figure out how many people they surveyed. Watch these national supposed surveys they do, and they get this 6% random error because they only surveyed like 100 people. Silly people. So, but again, those are the types of things that we're doing. And then I want to do one more down here. Let's pop down to 11A here. Okay, determine if we're a sample or a population. Then find the mean and the standard deviation of the data. So, let's see here. If we're doing A, are we in sample or population? Sample. Because we just have 12 students. And unless that's a really small high school, that is not all of them. So once I get that, we'll scooch this over just enough here. Again, we're going to go back in. We're going to hit Stat. My first option there is Edit. Well, we want to edit because we've got a list to put in. If you have numbers in your list and you want to clear them, again, arrow all the way up once you get into Stat and Edit to L, whatever your top row is, L1, L2, whatever it happens to be. Hit Clear once and then arrow back down and your column will be wiped out for you so you can start fresh. So once we get that set, we can basically just start doing some data entry here. Just reminding ourselves, especially if we're going really quick, to make sure when we get to the end, look at that last value and make sure the number of data points that you put in this case 12, matches up so you haven't gotten any extras or come up short one. Once we've got that, then we're ready to actually start getting all of our information out. So we're going to go with back to Stat, over to Calc. We want our variable statistics, number 1, and second, and hit the number of whatever your list title was. So if it's 1, hit 1. If it's L2, hit 2, and hit Enter, and we can start getting the information that we're looking for. So here, oops, mean, not M, my mean is going to be 7. And then my standard deviation, again, we've got to pay attention to the difference between, and I'll pop this back up too, between whether it's the sample or whether it's a population. Easiest way to remember this, and I'll shrink this back down for a second, pop this up from yesterday. Samples, it looks like there's an S in front. That makes sense. Okay. Populations. So we're just looking for those symbols as we look in the calculator. Let me get the calculator back up while we have them. Okay. So my sample is here. My population one would be here. So since we determined it was a sample, I'd go with the .86. If it would have been a population, I'd have done the 1.78 on that. Any questions so far? Because I want to make sure we're feeling okay with the stuff that was going on yesterday. I want to throw one more twist at you, and then I think I might have you set for this one. if we flip over, I want to take a look at 14. Okay, so 14. A poll was taken of registered voters to see if they plan to vote in the next presidential election. What's the margin of sampling error if the likely interval of those who plan on voting is between 46.5 and 49.5%? So they're giving me the interval this time, and they want me to figure out what the sampling error is going to be. Now remember how we calculated this before. We had that middle value, that middle percentage, and we added and subtracted a value. So let's see here. How far apart, or how large is our interval right here? 3, okay? So if I take that 3% and I split it, it means my margin of sampling error is about 1.5%. And here's how I can double check if I wanted to. If I took 46.5 and added 1.5, I get 48. If I take 49.5 and minus the 1.5, I get the same number in the middle. So this was probably the initial percentage of people that said they were going to plan to vote in the next presidential election. This was just me kind of working it backwards to see how that would end up working. Issues, issues, issues. Hi. So that sort of is more like our review, or kind of our second day look at some of those, and we'll be finishing those off. But I want to take a moment right now and look a little bit deeper into some of the things with populations and samples. Now I'm not going to read this verbatim because that would be kind of crazy and silly and put y'all to sleep. Instead, I want to take a peek at just a few highlights here, because when we're doing samples, there's more to them than just it's a sample or a population. There's types of sampling that you can do. And sometimes bias might show a little bit in there, which is again trying to sway people one way or the other. Okay. The easiest one that we do most of the time is simple random sampling. That's what we talk about most of our things in here, at least. Simple random. Equal probability of selection, okay, and that each member has an equal chance of being selected. So if I were to go around to all of you and just randomly start picking people and everybody had the same chance, I drew your name out of a hat, that'd be simple random sampling. It's not like I put some people's name in 3 times and other people's none. So again, we assume that's the sampling we're doing unless we're told otherwise. Cluster sampling is from a specific population. Now it's still random, but now I'm kind of narrowing down the group that I want to work with. And the example they give here is randomly selected sample of incoming freshmen to universities in southern states. I'm going to specific universities in a certain area, but once I get there, I'm putting some randomness into it. So it's sort of like the simple random sampling, but within a particular group. I guess that's what we'll kind of call it here. So simple within a specific group. So it's a little more narrowed down as far as who may get selected. So okay, simple, cluster, convenience. Easily obtained, okay? Higher risk of bias because now, for instance, I'm going to select a group of baseball fans attending the game on opening day in Boston. Now if I'm asking them, are you baseball fans? Well, that's kind of biased, okay? But it lets me get a lot of people in a very small area that I can work with. And so sometimes you've got to do things for convenience. I may want to know what honors Algebra 2 students do all over the country, but I don't have access to all of them. I have access to you. So my convenience sampling was, I'd assume with what you tell me would be what everybody would think. A little bit, like I said, on the dangerous side. Only one main one left here. Systematic sampling. It's like, holy cow, many kinds of sampling to work with here. It's assumed that we're arranged in some kind of order. You start and then you start sampling from there. So systematic sampling, selecting every 125th name in the greater Dallas area phone listing. Picking every 5th sophomore to ask a question to as I'm going in an alphabetical order. That would be an example of systematic sampling. And then our last one we're going to talk about, stratified sampling, means you're going to take groups and you're going to split them into 2 separate groups themselves. So for instance, the example they want to use here, looking for a stratified sampling surveying of all students at the high school about their opinions. The students are divided into the strata of male athletes and non-athletes, female athletes and non-female and non-athletic females. That would have been kind of weird, call them non-female athletes. That would not have worked. We'd have had the males back again, at least I think. But it's taking the groups and dividing them into smaller subgroups before you do their surveys. So how we're going to use that, just for a little bit of practice, and then we'll have you set, because that basically covered all the types we're going to run into here. So on the practice part, and we'll do a few of these, and then we'll just knock the rest of these out. So it'll be on 2AB and then 4AB here that we're going to be doing the homework. Name the type of sampling you think would be used, and some of these do have multiple answers. And then explain if you think the sample would be biased. So for instance, if we're taking a peek at 1, a company conducts a survey each spring to measure the morale of its employees. A group to be surveyed is randomly selected from all employees who have been with the company for exactly 5 years. Doesn't seem like that's completely random to me. Yes?
It seems like it's cluster.
And I think I would have to agree with that. Because again, when we look at cluster, it's a specific section of the population. So, I would agree with you. Looks to be cluster, because again, we're from a very specific population. Now, is that going to be biased? Yes. What do you think they could do? Either why is it biased, or what would you do to make it a little less biased?
They're only asking people who have been into the company for a good 5 years, and chances are if they hated their job, they would have left it by now.
Okay. So, right. You're only getting a small picture with that group. And I mean, you could even go on to say something like, maybe have some newer employees and some employees that have been there even longer to kind of see, you know, what's going well and what people are looking for change-wise. But just to try and understand a little bit, you know, okay, what's wrong with this, or how can I fix it, would be a good idea. Okay, we'll pop one more of these in, because then I think, yes. All right, last one in here. A school wants to get ideas on how to improve the cafeteria seating plan. A survey is conducted of all students in attendance at the November Student Council meeting. What type of sampling might we be taking a peek at this time? Because I immediately thought of 2 different ones when I saw this. Ooh, now that's not one that I'd thought of. Now, what would your strata be if you went to stratified? Because that would be when you're having multiple groups within a group.
Oh, absolutely.
All right, does it seem like it's simple? No. Simple, we just ask any student. We wouldn't be just looking at the student council meeting. Okay. Could it be cluster again? Okay, we'd have a specific group, and we may have the student council people at this meeting. Okay, could it be convenience?
Yeah.
Sure, they're already having a meeting. We're just going to happen to ask them some questions. So, and that's what I mean on a lot of these. Don't think that you have to go one route. Here, I absolutely can fight either of these. I could fight convenience. Now, would it be biased? Well, probably. Because I only have student council people representing everybody. Now, you'd say, but isn't student council supposed to represent everybody? Yes, they're supposed to. But some people may complain about that. But some people complain about everything. So, that's one way. If we went back to cluster, you'd basically come back to the same issue. I've only got this certain group of people, so my opinion on how the seating in the cafeteria doesn't matter just because I don't go to student council meetings. That's the type of thing you have to think about with this. But that just kind of gives you an idea of what we're doing and trying to go with the explanations. And the rest of the sheet does the same thing. It's just, is there a bias? What type of sampling are you doing? And that's what we're working today, because then tomorrow we're going to start working a little on standard deviation. So, knocking out the rest of worksheet 2 and worksheet 4 is the actual assignment, quote unquote, that we're going to be working on today to get sampling down before we get into the standard deviation tomorrow.